In this lecture, we will discuss about geometric distribution. So, geometric distribution. So, this geometric distribution is also a discrete probability distribution. So, we write down this as this is also a discrete probability distribution. This is also a discrete probability distribution. Now, we can define this distribution as an experiment consists of repeating trials. Consists of repeating trials until the first success. Until the first success. It means that we can take an example of a coin. Suppose we are going to toss a coin. So now we need head. So we toss a coin again and again until we get the head. So head is our success. So जैसे हमने फर्स्ट टाइम टॉस किया फर्स्ट टाइम वी गेट द टेल सेकंड टाइम टॉस किया फिर टेल आया फिर थर्ड टाइम टेल आया वी रिपीट द ट्रायल अगेन एंड अगेन अंटिल वी गेट द हेड तो जब तक हमें ट्रायल को परफॉर्म करना है जब तक हमें सक्सेस ना मिल जाए सक्सेस इज अवर हेड okay so now we can take a specific question related to that so that means number of trials before a specific outcome occurs. So a specific outcome is we need a head or tail. So that means we can take the example toss a coin. So we are going to toss a coin. So what is our success? Success we get as head. So we write down as waiting head will appear. Head will appear. So when you are going to toss, so there are only two options. So we have only two options. First option, either we get a head or we do not get a head. So that means first option here we consider as success. When we get a head, that means this is our success. Or either not getting a head means this is our failure. So there are two options. Either we getting a success or not getting a success means failure. So in this case, you see that when we are talking about the tossing of a coin or throwing of a dice, so the probability, so you can see that the probability of success or failure remains same. So you can so the probability of success or failure remains same in each trial. So now we can understand this. So suppose we are tossing a coin. So first column we consider dedicated to the unsuccessful toss. Unsuccessful toss. So when we get the unsuccessful toss means our success is heading head, getting ahead. Now we get the tail. So that is called the unsuccessful toss. So in unsuccessful toss, we calculate the waiting time period. So what is the waiting time period? But how many trials we do to get the success? So we write down as the waiting time, waiting time period. Okay. Next, we calculate the corresponding probability. Calculate the corresponding probability. Now, when we are tossing a coin, so you understand the thing. So what is the probability of getting ahead? So getting ahead. So this is our success. Success is head. So what is the probability of getting ahead is 1 by 2, and not getting ahead is also 1 by 2. Okay. So P equal to 1 by 2 and Q is equal to 1 by 2. Now we start the first trial. So when we start the first trial, in first trial we get the head. We get the head. So what is our waiting period? So there is no waiting period. That means zero. पहली बार में हमने टॉस किया और पहली बार में हमको हेड मिल गया. So there is no waiting period. So at that time, what is the probability? The probability is 1 by 2. Now again, what is the second chance? तो second chance means it may be possible कि first जब पहले हमने टॉस किया तो फर्स्ट टाइम हमको टेल मिला, देन वी गेट द हेड, फिर सेकंड टाइम में हेड आ गया. सो व्हाट इज द वेटिंग पीरियड? सो वेटिंग पीरियड इज 1. मतलब एक बार टॉस किया हमें टेल आया, देन दूसरी बार टॉस किया वी गेट द हेड, तो एक वेटिंग पीरियड रहा हमारा 1 टाइम. So one is the waiting period. So at that time, what is the probability? So the probability can be written as 1 by 2 into 1 by 2. So probability remains same. In each trial, we write down this thing. But the total probability you can write down as what is 1 by 4. Similarly, we move to the third chance. In first two chance, we get the failure, tail, then we get the head. So the waiting period is 2. So now the probability can be write down as 1 by 2 into 1 by 2 into 1 by 2. That will be 1 by 8. Similarly, we move to the next case. So the waiting period is 3. So then the probability remains same for each case. So we write down as that will be the 1 by 16. So the probability is 1 by 16. So the probability of success remains constant. So you remember this thing. So your probability of success होगी, probability of success remains constant. So probability of success remains constant. Now, how to draw this probability on graph? So graph पे draw करने के लिए same. We draw the axis. So here in horizontal axis we consider as 0, 1 means our waiting periods, 3. Now, this is our probability of getting ahead, which is fixed at 1 by 2, which is fixed. Now, first, when we have 0 waiting period, that is 1 by 2. So this is our 1 by 2, 0 is here. Now, when we have a 1 waiting period, so that is 1 by 4. So 1 by 4, suppose we consider this side, that is 1 by 4. Next is 1 by 8. 1 by 8 means here, and next is 1 by 16. So this is 1 by 16. So you consider by using the scale. So this is our representation. Now, so when we are going to calculate expected time, so how to calculate the expected time? So where we can calculate the expected time, so the expected value of x, this can be written as, because we do the 3 waiting period, we take for this one. So that means the value of x we can consider as x equal to 0 to 3 x into px, probability of x. So this can be written as So for x equal to 0, so that means we write down xi pi, so that it can be written as 0 into p, probability is 1 by 2, plus 1 into probability is 1 by 4, plus 2 into probability is 1 by 8, plus 3 into probability is 1 by 16. So this can be calculated as 1 by 4 plus 1 by 4 or plus 3 by 16. So we write down as 2 by 4. So 2 by 4 plus 3 by 16. So this can be written as 8 by 16 plus 3 by 16. So this will be the 11 by 16. So expected value or mean is 11 by 16. Now, so we can explain the geometric distribution. So we say that thus we have the series of independent trials. So we write down as we have the of independent trials. Series of independent trials, or we can say that the repetitions, and each trial, the probability of success, the probability of success p remains same. The probability that x failure proceed the success when we perform x plus 1 trials. So then we write down the things as, so we get the failure, 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 and so on, failure. Then we get the success. So here we have X failures. We have X failures. After X failure, you get the success. How many trials you have done? You have done the X plus 1 trials. So what is the probability of success? The probability of success is P, and probability of failure is Q. So then the probability mass function, then the probability mass function of geometric distribution, probability mass function of geometric distribution can be written as q raised to the power x into p, q raised to the power x into p, because q represents the probability of failure. So x time failure, then we get the success in x plus 1 trials. So we can write down this as q raised to the power x. So x times we get the failure, then we get the success. So this is our probability mass function of a geometric distribution. You can understand this thing as, जैसे हमने लिया success. Success means x equal to 0. That means no failure. This represents the no failure. First time we get the success, there is no failure. When we get the failure, then success, it means our x equal to 1. So means here we have one failure, then we get the success. So here we can write down as one failure, one failure. When we have a failure, failure, success, so here we can write down x equal to 2, means 2 failure, then we get the success. Then we get the success. Okay, so this is the probability mass function of geometric distribution. Now we can calculate the mean and variance of geometric distribution. So mean, first we start the mean or expected value, mean of geometric distribution, mean of geometric distribution. So mean, or basically we can say that the expected value. So mean we denoted as mu. Mu is equal to expectation of x is equal to summation of here we have x equal to 0, 1, 2, 3, and so on. So x equal to 0 to infinity, x and to px. So this can be written as summation x equal to 0, x into px. Px is the probability mass function of genetic function. So now when we open the summation, so we write down this as, so when we put x equal to 0, so 0 into q raised to the power 0 into p plus x equal to 1, q raised to the power 1 into p plus x raised to, so this gives us q square p plus 3p plus and so on. So now we write down this as qp plus 2 q square into p plus 3 q raised to the power 3 into p plus and so on. So here we take qp as common. So when we take qp as common, so this term we can write down as 1 plus 2q plus 3q square. Next term क्या होगा इसका 4q plus and so on. So this is the value of mean mu. Now we can give as equation number 1. So we multiply both side by, so in this we multiply both side by q. So we write down as q into mu is equal to qp. अब q से मल्टीप्लाई किया है तो साइड मल्टीप्लाई कर देंगे. दिस गिव्स अस 2q स्क्वायर प्लस 3q रेज टू द पावर 3 प्लस 4q रेज टू द पावर 4 plus and so on. Now, after multiplication, we give as equation number 2. Now, on subtracting, we do the 1 minus 2. So when we do 1 minus 2, so this can be written as mu minus q mu is equal to, अब QP दोनों में कॉमन है तो QP दोनों से कॉमन ले लिया. पहले फर्स्ट इक्वेशन लिख देंगे 1 प्लस 2q प्लस 3q स्क्वायर प्लस 4q रेज टू द पावर 3 प्लस एंड सो ऑन. और सेकंड में क्या आ जाएगा माइनस q प्लस 2q स्क्वायर प्लस 3q रेज टू द पावर 3 प्लस 4q रेज टू द पावर 4 plus and so on. So we can write down the mu we can take as common. So this can be written as 1 minus q. और इधर से क्या आ जाएगा qp into, so 1 1. So here we have a plus का 2q minus q. So this gives us plus q. Next is 3q square और minus का 2q square. So gives us plus का q square. 4q और 3q. So this gives us plus q or plus and so on. Plus and so on. So now we get this term. So this can be written as qp into. So this is the expansion of 1 minus q raised to the power minus 1. So this is the expansion of 1 minus q raised to the power minus 1. Or what is the value of 1 minus q? The value of 1 minus q is p. Okay, so we know that p plus q equal to 1. So q equal to 1 minus p. Probability of success plus failure equal to 1. So p to p cancelled. So this mu can be written as q upon 1 minus q. Or what is 1 minus q? Means p. So q upon p. So mu is equal to q upon p. So this is the mean. So when we know p and q, so when we write down the mean. So this is the mean of geometric distribution. Similarly, we can calculate the variance. So now we take one question related to that. So we start the question. Consider a repeated rolling of pair of fair dice. What is the probability? What is the probability that the first roll of double occurs on fourth roll. Second part, what is the expected waiting time expected waiting time means number of rolls before a double is rolled. So consider a repeated rolling of pair of fair dice. Pair of fair dice. So what is our success? So let we consider x. X is our success. Success is roll of double. Roll of double. So we can write down the pair of double. This will be 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. So this is the pair of doubles. That means same number occur. So now the probability of success. Probability of success. So we say that the probability P of success. So probability of success we write down PS. PS is equal to 6 by 36. क्योंकि सैंपल स्पेस क्या होगा 6 इंटू 6 इक्वल टू 36 और इवेंट क्या हो गया हमारा इवेंट हैविंग 6 एलिमेंट्स तो 6 by 36 तो प्रोबेबिलिटी ऑफ सक्सेस इज 1/6. So this probability of success 1/6 we denoted by small p and the probability of failure. तो probability of failure means डबल अकर नहीं होगा कहाँ नहीं हो कब नहीं होगा तो that will be the 1 minus probability of success. So 1 minus 1/6 that will be the 5/6. So this 5/6 can be represented as Q. So probability of success is P, probability of failure is Q, that is 5/6. Now we read the question. Question को पढ़ना है ये कह रहा है कि what is the probability that first roll of double occurs on fourth roll. मतलब थर्ड रोल तक आपको क्या मिलेगा फेलियर 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 देन यू गेट द सक्सेस. सो द सिचुएशन इज दैट व्हेन वी गेट द फर्स्ट फेलियर सेकंड फेलियर थर्ड फेलियर देन गेट द success. So success on fourth roll. This is first roll, second roll, third roll, and fourth roll. So we get the success on fourth roll. So probability of x, random variable x, so can be written as q raised to the power x. So q raised to the power x. Then we get the success. So q raised to the power x. So what is the value of x here? So what is the value of x here? The value of x is 3. So the value of x is 3. So generally we write down a q raised to the power x into p. So this can be written as q raised to the power 3 into p. So f failure we represented as x. So you can see that failure we represented as x, then we get the success. So we write down the probability mass function as q raised to the power x. ऐसे ही यहाँ पर हमने तीन फेलियर हैं देन सक्सेस है, so we can write down as q raised to the power 3 into p. So this is our probability mass function. तो ये फ्लेक्सिबल होगा ऑन द बेसिस ऑफ द क्वेश्चन, जो ज्योमेट्रिक डिस्ट्रीब्यूशन का probability mass function है. So now we can put the values. So Q, we put the value is 5 by 6 whole to the power 3 into probability P is 1 by 6. So this can be written as 5, 5 ja 25, 5 ja 125 upon 6, 6 the 36 is the 216. So into 1 by 6. So we can calculate that this probability approximately 0.096. So now we move to the second part. Second part is what is the expected waiting time. So expected waiting time is we calculate the mean. So we calculate the mean or expectation of x. क्या कैलकुलेट किया अभी हमने q अपॉन p. तो q क्या है वहां पर 5/6 है और p कितना है 1/6 है. सो दिस मीन्स 5. सो वेटिंग टाइम कितना हमारा 5 रोल्स. 5 रोल्स 5 रोल्स का अप्रोक्सीमेटिंग टाइम है. देन वी गेट द डबल. Okay, so we move to the next question. Question number 2. So a traffic signal on your way has green light for 40 seconds, green light for 40 seconds, and red light for 60 seconds. Red light for 60 seconds. So our question is that what is the probability the light will be green, the light will be green when you the intersection reach the intersection at least once in 5 working days. 5 working days. Okay, so this is real life questions we have faced on regular basis. So now when we calculate the total seconds, so total seconds are 40 plus 60. So we write down as total seconds, that is 40-second green light, 60-second red light, total seconds are 100 seconds. So now we calculate the probability of green light. Probability of green light. The green light is our success. So what is the probability of green light is 40 upon 100. So this we can write down as 0.4. Okay. So we can write down as, so we take green light as success. Okay, हमें तो ग्रीन लाइट पे ही सिग्नल क्रॉस करना है, so we consider as a success. So now probability of success, that is 0.4, we can denote it as small p. So what is the probability of failure? So that can be calculated as, so probability of failure will be 0.6, that we can write down as q. Now, so after writing probability of success and failure, so we generate the random variable. So we write down the random variable x we consider as green, or green we consider as the success. So now we can write down the things, that is, first day we can cross the intersection, we get the green light. So this is our success in first attempt in 5 days. Okay. Now second situation, maybe we get the failure, then we get the success. Third situation, maybe failure, failure, then success. Fourth, maybe failure, 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 then success. And fifth day, we get the failure, 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 and success. So these are the situations in 5 working days. So now we calculate the probability. So we cross at least once. So for calculating the probability to reach the intersection at least once is, so we write down as probability of random variable x less than equal to 5. So less than equal to 5, this can be calculated as first case, that is success. So that means we write down as zero point 0.4 plus second will be failure. Failure is zero point 0.6 into success is zero point 0.4. Third will be failure, failure, success. Next will be failure, 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 then success. And next will be failure, 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 then success. So we calculate the at least once. So this can be simplified. So the answer is approximately 0.922. So 92% chances are there you cross the intersection at least once in 5 working days. So 92% chances are there to cross the intersection at least once in 5 working days. Okay, so now we calculate the expected number of days. So second part we can add in this. So what is the expected number of days? What is the expected number of days before the light is green? When you reach the intersection, when you reach the intersection. So we calculate the expected value. So the expected value that we can write down as expectation of x, or means mu, which is equal to q upon p. So this q upon p we can write down as 0.6 upon zero point 0.4. So that can be written as 6 by 4. So that my is 3 by 2. So 1.5 days. So the expected time is 1.5 days. After 1.5 days, we get the green light.